everyone, welcome back to another video about math. Today we're going to be talking about statistics. Oh, the joy! Oh, lovely goody gumdrops. Well, where should we start? Well, let's start with what's easy. How about number 8? A sum of values divided by the number of individuals there are. That looks like C to me. Number 9, how much variation exists from the mean? That's kind of like measure of spread, like how much spread there is, how much variation there is. So that would be standard deviation. And I think number 10 is also pretty straightforward. The midpoint of a frequency distribution, that sounds like a median. Number 7, a distribution where the mean is greater than the median. Well, if the mean is greater, so imagine like, your numbers are like 10, 12, 13, 14, and then all of a sudden one number is a million. Well, your mean is going to go way to the right, but your median's is not going to move much, right? Or maybe not even at all, depending on the numbers. And so that means that your mean is going to go way higher. So yes, that would put the tail out to the right. It would give you an outlier on the right, and it would mean the mean is greater than the median. And so therefore that is right skewed. So that would be B. And that helps me to remember that this one up here, number 3, is D. Then 3/4 of the observations are below that. That's the third quartile. So let's do that. Individuals are placed in groups that take on numerical values. Numerical values are quantitative variables, so that would be H. And the other ones are a little bit more difficult. So number 2, if the 5 is H, if 5 is the quantitative, then the group 1 is not that one, categorical variable. There we go, J. No, wait. Yes, that would be J. Distribution of categorical variables in a two-way table of counts among all individuals described in the table. So all tells you totals, and totals mean marginal. So that has to be A. And then specific ones are the conditional ones. So that would be E. And that's how it is. There you go. Have fun. All right. As always, please pause video before you listen to the explanation. And we're back. An office supply catalog gives a description of desks with the following variables. Which of these categorical? The color, yes. Height is a number, weight is a number, width is a number, width is a number. All the rest are numbers, but color is not a number. And so that's why it's a categorical variable. Number 12. A consumer group surveyed the prices and reported an average price of 16. Now, we haven't really done a lot of questions like this. We do know what mean is. We do know that mean equals sum of terms divided by the number of terms. So in this case, we have 4 values and 1 unknown. So what I'm going to do is I'm going to put that as my sum. So I'm going to have 12 plus 14 plus 17 plus 23 plus some unknown, which I'll call X, divided by, how many numbers will there be? Well, there's going to be 5 stores, so the number of stores is 5. So that's what I do here. And the mean is also given. The mean is 16. So really, this is just a matter of setting the problem up. You just set the problem up with the information that you know. And then you simplify. So this means that 16 equals something over 5. And that's going to be 40 plus 26, so 66. 66 plus X. Now what? Well, we can multiply both sides by 5. And that gives me, well, not like that. Let's move that over here. Give ourselves a little bit more room. So that means that 80 equals 66 plus x. And if you subtract 66 from both sides, you'll get that x is 14. And that is the one unknown that we don't have. And that's how you do it. Make sure you look at the way that I did it. It's actually not how I did it. I just want to show you another way to do it. In my brain, I said this is 4 under the average. This is 2 under the average. This is 1 above the average. And this is 7 above the average. And I add all those up, and I'm like, 8 minus 6. Hey, that's 2. I'm 2 above the average, so I need to get 2 below the average. So I did 16 minus 2, and I got 14. That's how I did it. Just pause the video and rewind it and play that again until that makes sense to you. You might have to listen to that a couple times. But it's called like balanced average. So that's how I did it. I don't have time to go any more into that. So number 13. A set of data has a mean that is more than the median. All right. Which of the following statements is most consistent? Well, if you got the one correct up top, you would now know that if the mean is more, that means it's skewed right. Next problem. Number 14. Birth rates, blah, blah, blah. Here's the results. Bunch of numbers. And they give it to us with the data and also a dot plot. That was nice of them. 5-number summary. Well, start with the minimum. That's always the easiest. The minimum is clearly 14. And again, pause the video if you want to do this on your own. The maximum clearly is 53. That's the biggest number. The median is a little bit tougher. How many numbers are there? Well, if you count them all up, you'll see that there's 54 numbers. And the way I did it is I just said, hey, this is 5. You know, each column is 5, and then there's 10 of those columns. That's 50. Plus these 4 at the end, that's 54. So there's 54. That means between the 27th and 28th number. Why 27? Because 27 is half of 54. And it's an even number, so that means I have to average the half and the 1 to the right of that. So 27 is half of 54. So I have to average the 27th and 28th numbers, and that will give me the median. So 5, 10, 15, 20, 25, 26, 27. And so the median is in between 37 and 38. So the median is 37.5. And this now gives me 2 equal sets of 27 numbers. 27 is an odd number. If it's an odd number of numbers, you can just take half and round up. So half of 27 is 13.5, round up is 14. So that means the 14th number will be Q1, the 14th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 29. Then Q3 will also be the 14th number, but in the upper half. So I go from here and I count 1, 2, 3, 8, 13, 14. So 3, 8, 13, 14 is 41. And that's the 5-number summary. I'm done with that. Then they want a box plot. Box plot is just 5-number summary on a number line with some lines. So it doesn't have to be totally correctly spaced. I mean, it would help if you would try to space it somewhat correctly. But ultimately, the more important part is that you get the numbers right. So median is 37.5. And then Q1 is 29. Okay, and so we just remember to make these bigger. And then we connect the Q's. And then we also connect the middle part for our whiskers. And that's it. You can label these. In fact, you should label them. minimum, maximum, Q1, Q3, and then in the middle we have median. And I don't know why I put it on top. It could be on the bottom, but that's the box plot. Are there any outliers? Well, what's the IQR? The IQR is Q3 minus Q1. So in this case, that would be 12, right? 12. And so for the outliers, we do 12 times 1.5, which is 18. And you add 18 to Q3. So Q3 plus 18, anything greater than that would be an outlier, or anything less than Q1 minus 18. Q3 plus 18 happens to be 59, and Q1 minus 18 happens to be 11. But there are no numbers less than 11, and there are no numbers greater than 59. If you look back at the list, there are no outliers. So we're just going to say no outliers. And that concludes that problem. It looked really hard, especially because it was all those numbers. But, you know, it wasn't that hard. Number 15, 5 students reported the amount of time they spent. And we have these numbers. We have 5 numbers. And so we have to calculate the mean and standard deviation. So let's do the mean. We're going to add all these up. That's going to be 150, 250, 335, I believe. Tell me if I'm wrong. But that is the mean. And hopefully you remember the steps for the standard deviation. Basically, once you have the mean, you can subtract that from each one. And so our numbers are going to, whoops. I forgot to divide by 5. Okay, so that's 67. So we're going to subtract 40 from 67, and we get 27. We're going to subtract, why is it not working? We're going to subtract 55 from 67, and we get 12. We're going to subtract 60 from 67, and we get 7. And it doesn't matter which order you go. You can also subtract the mean from the number, and I'm going to do that with 85 because it's larger. And that's going to give me 18. And then 95 minus 67 is going to be 28. And so now I have my new 5 numbers. Now I'm going to square each one. And so this one here now, square this, square that, square that, square that, square that. Okay? And so I already know what 12 squared is. 27 squared, do I do it in my head? I'm just going to, I could probably, but I'm not going to do it. 729 plus 49. I think this one's like, what is it, like 324 or something? Yes, it is 324. Okay, good. And then 28 squared, which is 784. And then you add all those up. And what you get is, of course, the number 2030. Once you have that sum, we have to divide by how many there are. So that's 406. And then we take the square root of that. And we get 20.14. And that's our standard deviation. I think that's it. Interpret the mean and standard deviation in context. Okay, well, I mean, within one standard deviation, 67 plus 20, so you have 87. 67 minus 20 is like 47. So the first 3 numbers, the 3 middle numbers are within one standard deviation of the mean. So, you know, most people studied somewhere in that amount. And, you know, I don't know. There's a standard deviation. That's all there is. Well, I hope that was helpful to you. Thank you very much. Good luck. Please like, share, and subscribe, and buy my merch.